Meeting is being recorded. Okay, well, hi everyone. Thanks for coming back. I hope no one was trying to connect last Monday. I was traveling. That was the reason we couldn't hold the session. Just so you know, Boston up here is in a day of mourning. Our baseball team lost last night out of the playoff series, but I wish the other remaining teams well. But football season is on the rise now, so maybe the football team will do better. But anyway, it's a beautiful day here in Boston. It's in the middle of our early fall, maybe mid-fall. The foliage is turning. It's very pretty, but cool. 50 degrees Fahrenheit right now. So winter is on its way. So I envy those of you who are in Hawaii, and I suspect those of you who are in Alaska, you've already seen the cool weather earlier. So anyway, biostatistics, just to get a feeling for what we're doing. The first 4 sessions we covered a big picture review of epidemiology, mostly study design issues. Now for the next 5 sessions, I want to talk about analysis. And then we'll end the sessions up later this fall, early winter, by talking about programming and SAS. So what I want to do today, let me see if I can get this pointer working, is talk about statistical analysis. And primarily today, I just want to make sure we're all on the same page when we talk about tests of significance, and when we talk about confidence intervals, because those are 2 ways we try to make inference from data. So that's what we're heading into today. And I thought it might be useful to go back to a few weeks ago and to just show a few slides that I think we skipped over as an introduction to this. Remember a couple of plans. It's the latter that I'm interested in today, the statistical analysis plan. So let's start by just talking about how you would develop a plan to analyze data that you've collected from some sort of a research study. And basically, if you read manuscripts, and manuscripts are always broken into sections. There's an introduction section, followed by a method section, followed by a results section, followed by a discussion section. Well, it's usually in the method section where you see the analytical plan being laid out to the reader. It's usually at the very end of the method section. And some journals put this method section in smaller font, which might mean that it's not as important to read. That might be true if you are just looking for the main results and not interested in how the results were obtained, how the study was designed, how the data was collected, how the analysis was done. But a educated consumer should evaluate any paper they read for its merits to decide whether this is a conclusion that you want to believe or not to believe that are reached from this paper. So let's talk about method section in the statistical analysis plan. And usually the analysis plan contains 2 things. There's some descriptive statistics that give the reader an idea of who was in this study, what those people were like in terms of their age and their sex and their other conditions. But there's also an analytical portion where the actual conclusions are being reached by looking at associations between risk factors and outcomes. And by going a step further by saying whether those associations are statistically significant or whether those associations are consistent with certain findings in terms of displaying confidence intervals. And we'll talk about both of those today. And the key point I just want you to think about, whenever you do a study, and you're thinking about the analysis you're likely to do once the data are collected from this study, typically the way you do that is imagine the paper you're going to write. And in that paper, the first thing you should be thinking about are what are the tables and what are the figures you're going to be showing the reader? Because that drives the analysis that you're going to be doing. So when you're putting together an analysis plan, think of it in terms of the tables and figures that you'd like to show the reader. And everything should follow smoothly from that. So let's describe a little bit about this in terms of the plan. The first table you're likely to show to a reader, table 1, is probably going to be a description of the data set. You're going to describe who's in your study, what their average ages are, how many of them are men, how many of them are women, how many of them have diabetes, what's their body mass index, and things like that. What you're giving the reader is a basis to generalize these results. So if you show me a study that's mostly made up of old white men, then the results are likely to be generalized to old white men in general, and unlikely to be easily generalized to females. So what the description in Table 1 allows a reader to do is to get an idea of who were the types of people in this study, and then get an idea of whether the results from this study might be generalizable to larger populations, and if so, what types of populations. But Table 1 also serves another main role. You're looking at the relationship between a risk factor and an outcome. And we looked at a few of these a few weeks ago when we looked at the papers that I asked you to read. And you might want to know whether people who self-declare themselves to be in a certain acculturation group are more likely to be diabetic or not diabetic. But what I'd like to know is how similar are the people in various acculturation groups? Do they have similar ages? Do they have similar sexes? Do they have similar characteristics with other factors that might be risk factors for developing diabetes? Because if they're not similar, you're going to have a problem deciding whether any association you see in your data set is due to confounding or not, as we talked about a couple of weeks ago. So, and that tells us how our results are going to be likely to be valid or not, or whether we're going to have to do some adjustment in our analysis. Now, the big question I think people struggle with when they think of this first table is whether you add p-values to describe the two groups you're comparing, whether they're significantly different with respect to their age or significantly different with respect to their body mass index. And I believe that the jury is out on that, on the use or non-use of p-values. I'll give you a couple of tables from paper and at least give you my opinion on whether p-values are appropriate or not. But I'd say about half the papers I read, I look at a table 1 and they're comparing two groups of people, trying to describe how comparable they are. About half of them will talk about those characteristics being significantly different or not, and half of them won't. Half of them will add p-values and half of them won't. Now that's what Table 1 is, a mixture of description and trying to describe how comparable groups are. Table 2 typically describes the crude relationship between your risk factor of interest, acculturation group, and your outcome, prevalence of diabetes. So in part, it also is descriptive. It's describing how common the outcome is in the various groups you're comparing. But it also might be the basis for doing some inferential statements. You might see a p-value reported there. You might see a confidence interval built around a measure of association. And whether you do that or not really depends on whether you believe you have confounding in your data set or not. If you do, then the association you see in this crude table could well be a reflection of not the effect of the risk factor of interest, but the effect of the confounding factors. And therefore, trying to talk about whether that association is statistically significant or not is really not a useful exercise. So whether Table 2 contains p-values and confidence intervals really depends on whether you have confounding or not. Now, Table 3 is typically a table where you show the adjusted analysis results. If you're adjusting for confounding factors through some regression model, you might be showing the results from that model, and that usually gives a measure of effect, odds ratio or risk ratio with a confidence interval around that measure, or a measure of effect with a p-value, telling whether that measure is statistically significant or not. And finally, sometimes you'll see other tables or figures. For example, if you're doing subgroup analyses on certain people, and if you're interested in just looking at women, different acculturation groups, you might put that into a separate table. If you have other outcomes besides your primary outcome, you might put those in a separate table. But in general, that's a common flow of what tables look like, and that describes what type of analysis you're going to be doing once your data set is collected. So let me give you a few examples, and we've seen these examples before. If you remember, we looked at one paper looking at the type of insurance coverage you had in terms of how much copayment you had to pay, and whether the amount of copayment was related to the compliance of taking a prescribed medication. And Table 1 in that document showed 3 different groups of people, broken down by how much copayment they had to pay for certain drugs. One had a